Hello everyone, welcome to Sinx classes. In today's lecture, we are going to discuss problem number 5, 6, 7 of exercise 3.4, chapter 3, which is part of trigonometric functions. In previous lectures, we have already covered exercise 3.3 and some problems of 3.4 exercise as well. In today's lecture, we'll start with problem number 5 and problem number 5 to 9, you've been asked to find the general solution of each of the following equations. Alright, so you have been given some equation, you have to solve and find the general equation of it. So again, our method would remain the same. We will remember the concept and we'll apply those concepts over here. So our concepts remain the same, whatever we had done in the previous exercise. So these three simple formulas we have to remember. When my sin x equals to sin y, then my general solution becomes x equals to n pi plus minus 1 to the power n into y, and when it is cos x equals to cos y, then my x becomes 2n pi plus minus y, and the third one is when tan x equals to tan y, right, then your x becomes what? Your x becomes n pi plus y. Alright. So these are some of the formulae you have to remember, and then finally there are two more, and I hope you already know it, but still we will do it. So one is, say if in this special case of it, then sin x equals to 0, right, which means it is either sine of 0 or sine of pi, right? So any multiple of pi would be 0. So in this case, my general equation generally is written as x equals to n pi, which is the special case. If you put it over here, you can see, right, it's n pi plus minus 1 to the power n into 0, right? So this is n pi anyhow, right? So x equals to n pi is 1, and then second one we got to remember is when cos x equals to 0, this means that it's an odd multiple of pi by 2, right? So first of all, this will be cos of pi by 2, then it will also be equal to cos of 3 pi by 2, and so on and so forth, right? So in this case, we can just simply write x equals to 2n plus 1 into pi by 2, right? Why? Because you see that these are odd multiples of pi by 2, right? But even if you write it like this, which we have learned, x equals to 2n pi plus minus pi by 2, if you had written like this, right? And this is also okay to write like this, but it's much better to write it in this format than the other one, right? So hope this part is clear to you. If not, just write me in the comment section below and I'll be happy to answer your questions. Alright, now let's move on to the actual problem. My first problem is this cos 4x equals to cos of 2x. Alright, what I can do is I can write it like cos of 4x, and then I can bring cos 2x on this side. This becomes cos of 2x. Now I also know the formula of cos c minus cos d. This will become minus of 2 of sine of c plus d by 2, which is nothing but 4x plus 2x by 2 into sine of c minus d by 2, which is nothing but 4x minus 2x by 2 equals to 0. Which formula I have used? I have used this formula, cos of c plus cos of c minus cos of d, alright, which is nothing but minus of 2 of sine of c plus d by 2 into sine of c minus d by 2. Alright, this is the formula I have used. Now, when you look at this expression, you can send 2 on the other side, and this becomes sine of 4x plus 2x by 2 is 3x, 6x by 2, right? 4x minus 2x by 2 is sine x, right? Equals to 0. Now in this case, either sine 3x is 0 or sine x is 0. So I can write either sine 3x is 0 or sin x is 0. Why? Because if this is becoming 0, this means that one of these quantity is 0, right? So either sin 3x is 0 or sin x is 0. Alright. Now solve these two separately. We have just concluded that if sin 3x equals to 0, I can just write it as sin 3x equals to sine of n pi. Right? Similarly, I can write it sin of x equals to sine of n pi as well. Nx equals to n pi here, and in this case 3x is equals to n pi, so x equals to n pi by 3. So what has happened here is I have got two solutions of x. One is n pi by 3 or second is n pi. So we'll have to write it like this. So x equals to what? X equals to n pi by 3 or n pi. Alright. If you have any issue of understanding how this 3x equals to n pi we have got, you can just look at what I have done over here. When sin x equals to 0, we just write it like this, n pi plus minus 1 to the power 0, right? Sin x equals to 0, and this is what we will get over here, right? And so that's the reason whenever we get something like this, we just simply write this is equal to n pi, and this is what we get. Alright, hope this is clear. Now let's go on to the next problem. What is my next problem? My next problem has got cos 3x plus cos x, and then there is minus cos of 2x equals to 0. So I can see that there are two terms in summation, and one is a negation, right? Let's try to solve the part in the summation and see what we get, right? And actually, when you look at this problem closely, when I look at this part, right, what I see is that if I try to solve it, this is cos c plus cos d, right? And what is the formula for cos c plus cos d? My formula for cos c plus cos d is 2 of cos of c plus d by 2 into cos of c minus d by 2. And what will be my c plus d by 2 here will be 3x plus 2x by 2, and then the other one will be 3x minus x by 2. So in that case, what will happen that I will be able to take out cos 2x common, and then again I will be able to write it in the factor of 2 things, right? So that's the reason I will start with this. There is no harm if you start with cos 3x minus cos 2x also, right? But let's start with the one which I had mentioned. So I will take what? I will take cos 3x plus cos x minus cos 2x, right, equals to 0. Not LHS, we don't have to prove, but rather we are trying to solve this equation, right? So now I'll take this and this together. So I'll say 2 of cos of c plus d by 2, which is nothing but 3x plus x by 2 into cos of 3x minus x by 2, c minus d by 2, right? And this minus cos 2x will be minus 2x itself, right? Now 2 of cos 3x plus x by 2, which will become what? 4x by 2, which will become 2x, cos of 2x, and this is 3x minus x by 2, which will become what? It will become 3x minus x by 2, which will be 2x by 2, right? Which will be cos of x, alright? So this is cos of x, and then I'll have cos of 2x as well. I will have cos of 2x as well, right? So what I'll do is I can just take this cos 2x common. When I take cos 2x common, what will I left with? I'll be left with 2 of cos of x minus 1 equals to 0, right? So now you can see that this is again a product of two things, right? And we know that when there is like the product of two things is 0, then one of these will be 0, right? So from here what I can derive is either cos 2x is 0 or your 2 cos x minus 1 is 0, right? Which is 2 cos x minus 1 is 0, right? This is this or this, right? And we have just done it in the previous slide that cos 2x when cos 2x equals to 0, we have done it in the previous slide that when cos 2x equals to 0, what will be the value? You know that when such thing happens, then 2x would become what? Or rather, let's take 2 steps. So this will be cos 2x would be what? Cos 2x would be cos of 2n plus 1 into pi by 2, right? Why this happens? Because it's an odd multiple of pi by 2, and then odd multiple of pi by 2 is always 0, right? So with this, what we get here on the left side is, we get 2x is nothing but 2n plus 1 into pi by 2, right? So this means that what we get we get x equals to what? 2n plus 1 into pi by 4, isn't it? So this is what we got it, right? Now on the other side we have got 2x cos x, 2 cos x equals to 1. This means that cos x equals to 1 by 2. And when will be cos x 1 by 2 in positive? When we are in the first quadrant or the fourth quadrant, right? So either here in first quadrant or the fourth quadrant, the cos would be positive. So when is my cos x equals to 1 by 2? When it is cos of pi by 3 or it's cos of minus pi by 3, right? In either case, it will be either this way or that way, right? Either pi by this theta or this minus theta, right? If that being the case, we know our general solution. We take this the first one, and x becomes what? 2n pi plus minus pi by 3, and where n is element of z, here as well n is element of z, right? So what we have got finally is x equals to what? 1 is 2n plus 1 into pi by 4, right? What we have got? First one is 2n plus 1 into pi by 4, or we have got 2n pi plus minus pi by 3. Alright, so these are the two solutions we have got, right? Let's move on to the third question. What's my third question? My third question is having sin 2x plus cos x equals to 0. So in just like in all other previous cases, we look at the expression and try to reduce it to some expression wherein it is a combination of 1 and 2, so that we can get either this as 0 or this as 0, and then we'll be able to solve it. So we will do the same thing here. While what we'll do is sin 2x plus cos x equals to 0. We know that sin 2x is nothing but 2 of sin of x into cos of x, right? And then cos of x is cos of x, we'll keep it as is. And then we are able to again take the cos x out as common. Then we are left with 2 sin x plus 1. So it's again reduced to 2 products, right? So alright, this is reduced to 2 products, right? So what will happen? Either cos x is 0 or this part is 0, alright? I think you can understand this part after following the third question, right? So cos x, either cos x equals to 0 or 2 sin x plus 1 is equal to 0, alright? And in this case, we know that when cos x equals to 0, we can just simply write x equals to 2n plus 1 into pi by 2. Simply, this is my general solution. And the other one, let's try to solve it. When 2 sin x plus 1 equals to 0, then what will be my 2 sin x? My 2 sin x is nothing but minus 1. And sin x will be what? Sin x will be minus 1 by 2. Alright. Now, my sin x is coming in negative. So, where all sin x is negative? In third quadrant and fourth quadrant. Right. So, if you know the value, I can just write, so I can just write minus 1 by 2 as sine of pi plus pi by 6. So, we know that sine pi plus pi by 6 is in third quadrant, and sine pi by 6 will be 1 by 2, but when it comes out, it will be again negative of minus 1 by 2. Or I can just go on the fourth quadrant and I can just write 2 pi minus pi by 6. Both of these will be the values. But I'll work with the first one itself because that's how we derive the general solution. So my sin x is becoming, let's sum it up. So this will become 6 pi plus pi. This will be 7 pi by 6. And this will be basically what? 6 to 12 minus pi, 11 pi by 6. So given this sine of this and sine of this, we know that my general solution will be x equals to n pi plus minus 1 to the power n, and I can write 7 pi by 6, the first value I'll take. So now I've got two values, so I can write the answer as x is equals to 2n plus 1 into pi by 2. This is my first one, right? And then I can write or x equals to, this is the one, n pi plus minus 1 to the power n into 7 pi by 6. Alright. So yeah, these are the answers, and in all three equations what we have done is we have tried to reduce the expression into some product of 2 or more functions, and once we have got that, we have just equated each of them to 0 and then got the value. So in all these problems, what you will get over here is that even if you put the value of this x equals to 2n plus 1 into pi by 2 in this equation, when you put this value over here, you will start getting 0. So let's do that and see one of the examples. So either this or this, right? So I take what? So I have to calculate the expression sine of 2x plus cos of x, right? And I take this value, right? So what will this become? Sine of 2 into 2n plus 1 into pi by 2, right? 2 will cancel out, plus cos of 2n plus 1 into pi by 2, right? Now this expression is what? This one has become sine of 2n plus 1 into pi, and this one has become plus cos of 2n plus 1 into pi by 2. I know that any multiple of pi would be 0, this will be 0, and same way cos of 2n plus 1 into pi by 2, this is an odd multiple of pi by 2, so this will also be 0, so cos is 0 plus 0. Again, when you put this value over here, we will get the same result. So yeah, this is what we do when we are trying to find the general solution of an equation. We try working with this system wherein you try to reduce the expression to two products and then get the values. Alright, hope everything is clear. If not, please do ask me questions in the comment section below and I'll be happy to answer your questions. Thank you for watching. Have a nice day.